I have I My name is Kunaljan. I am a mechanical engineer. I am from Gwalior. I have done my schooling from the Woodstock School with um, 87.4% in 10th class and 83% in 12th class. I did my engineering from Devi Ahilya Vishwavidyalaya Indore with 6.66 CGPA or 66%. And my final year project was the water hammering effect. I also worked in a Hpcl competition, SAE India Northern section, where I was working as a roll cage subsystem worker. And after that, I have some weaknesses like I'm quite he, I feel humiliated easily, and I am a overthinker. I have strengths like I'm a hard worker. I like doing new stuff. I am an artistic person, and I have some leadership qualities. I am also a friendly person and compassionate towards the environment. After that, uh, yes, sir, that's all. That's my introduction.
Great. Yeah. Essentially, what I'm doing is I'm also writing down some of the points for your review. Okay. So if I'm looking
Yes,
down, I'm just writing down. So don't worry about it. Okay, Kunal.
all right,
So
sir.
why do you want to join HPCL?
So HPCL is a very prestigious platform, and it has a really good growth opportunity. The deputy general managers of this company could be searched on Google. Um, so that tells that so many people knows them. So that is a really prestigious post. So I would like to go till that level in my future career if I get selected.
Okay, so whatever the things that you are mentioning, the qualities that you are mentioning in HPCL, so all other PSUs also offer more or less same thing. So I mean,
Yes,
if you join here and then ONGC calls you up, IOCL calls you up, will you go
yes, sir.
and join them?
So I think that I have heard a very really good reviews about HPCL, and I will have to work in oil rigs in the ONGC. So I would not do like to work at oil rigs. I would like more to work in the marketing section, which is larger in case of HPCL. ONGC is more related to refinery work and production work, but I am more inclined towards the marketing work because I like the field job so much. So I might not join any other organization other than HPCL.
Yeah, that's good actually. So what are the subjects you have command on?
So I have command on the subjects like heat exchangers, boilers, and fluid because that was my project subject. And
Okay,
yes, sir. And machine design maybe
what do you
because
mean by
designing.
maybe?
No, sir. Sorry, sir. Not maybe. I'm sorry, sir. So machine design because I have done designing in my school college time as a FE cycle project. So yes, that is the
What is turbulent flow, Kunal?
turbulent flow. When there is a too much intermixing in the liquid and the Reynolds number is very high, more than the critical Reynolds number, that is the turbulent flow.
So why does a high Reynolds number result into turbulent flow?
Because higher Reynolds numbers results into higher turbulent flow because the velocity is too high. Reynolds number formula says rho v L by mu that for a flat plate. So, sir, the velocity might be high, that would result into turbulent flow, or the viscosity is too high, that would result into higher uh, turbu- sorry, viscosity is very low, that would result into high intermixing.
Yes,
So
that's what I'm
basically,
saying. Why does
yes,
this
sir.
happen? Why a higher Reynolds number result
Yes, sir.
into a turbulent flow? What is Reynolds number?
So Reynolds number is a dimensionless number that says inertia force upon uh, viscous force.
Correct. Now, can you answer the question? What does a high Reynolds number mean, and why
Yes,
does
sir.
it result into turbulent flow?
Yes, sir. That has taken me to the conclusion that higher Reynolds number is that inertial force is higher as compared to viscous forces. That leads to turbulent flow or and higher Reynolds number.
Correct, correct. So, can you give me some application of viscosity, maybe, where we use
Yes, sir.
the viscous fluid, we use the property of the fluid being viscous.
Yes, sir. Once a minute, sir. Let me think for a second, sir.
Yes, please.
Uh, Sir, the when the plate moving on a inclined when we place a plate on a fluid, so we can move it with a constant velocity. That is due to viscosity. If there is no viscosity, then the velocity would increase continuously. No, I'm sorry, sir. I'm unable to think about the application. So sorry.
Okay, okay, that's okay. What
Yes,
are
sir.
bearings in machine design or theory of machine?
Yes, sir. So bearings, um, that bearings are the supports that are given to a member relative to whom the relative motion takes place.
Correct. Usually, the relative motion is circular in nature.
Yes, sir. Usually it
Correct.
is
So,
circular.
what are the types of bearing?
So we have hydrostatic bearings, hydrodynamic bearings, roller bearings, mm, and yes, sir. That's it, sir.
Correct. Fine. What's difference between hydrostatic and hydrodynamic bearing?
For hydrostatic bearing, we require um, hydrostatic bearing. We require what do we say that? External hydrostatic bearing and hydrodynamic bearing. Hydrostatic and hydrodynamic. Hydrostatic bearing, we have to give an external torque to make the motion, and then hydrodynamic bearing. Uh, w- yes, sir. Sir, in hydrostatic bearing, we don't need to give external torque. It it gets its own torque when it gets rotated. And in hydrodynamic bearing, we have to apply external torque to make it in motion.
So,
Sir, actually, I'm sorry, sir. I'm sorry, sir. I'm saying ulta. Actually, hydrostatic bearing, we have to apply external torque, and hydrodynamic bearing, it has its own torque, and it can lose contact on its own. And in
correct.
hydrostatic bearing, we have to apply out external torque.
Okay. So, where do we apply this external torque that you are talking about?
So this torque is applied in the fluid, on the
Okay.
fluid, so that
How can
fluid
you
is.
apply torque to a fluid?
So we
Is torque the correct word here?
No, sir. It's not the correct work. We make the fluid in motion with the help of a pump.
Correct. Correct. So essentially, we bring in the layer of oil using a pump.
Yes, sir.
Okay. So we don't give torque actually.
Yes, sir.
Okay. Great. Perfect. So, what is ductility?
Ductility of a material to be formed into a wire.
Okay.
The
So,
property of a material to be
so that
formed
is
into
a
a wire.
definition as per class 7th. I want a
Yes, sir.
definition of a BTech graduate.
Right, sir. Sir, after the yield point, there is elongation in the material until the material breaks. It stretches uh, until according to its toughness, it stretches, and that is the amount of stretch it gets is called the ductility of that material. So,
Correct. It's a deformation that we talk about.
yes, sir.
Which type of deformation is that?
So it is plastic deformation.
Correct. So whenever if someone asks you what is ductility, never say it's, ability to be drawn into wire.
Yes, sir.
Say it's the ability of a material.
sir.
to sustain a plastic deformation.
Yes, sir.
Okay, and what is
Okay,
the
sir.
brittle materials then?
So brittle materials that do not deform plastically, they break instead very
Correct.
fast.
Okay. Okay. So imagine there are, two supports and there is a
Yes,
beam
sir.
in between.
Yes, sir. Yes, sir.
Okay, and it's a fixed support. Now,
Yes, sir.
let's say the beam has length L or something like that, and now I
Yes, sir.
hit up the beam.
Yes, sir.
It has fixed support. What will happen?
The stresses will be developed in the beam.
Correct.
Compressive
Which type of
stresses.
stress? Compressive stress.
Compressive
Okay.
stress.
Okay. Fine.
Yes.
What will be the length of the beam now? Now that I have heated it.
So the length of the beam will be the same.
Okay. Now, imagine the beam could go into buckling zone as well. The beam could buckle.
Yes, sir.
Now what will happen? Can the beam buckle in this case? What is buckling?
So buckling is the when the load is applied axially on a beam,
Mm-hmm.
then it's a column. When the load is applied on a column, then it deforms perpendicular to the axis. That is buckling, sir.
Okay, so now you have this beam, you are hitting it up in between the two fixed support. Can it buckle?
Yes, sir. It can buckle, sir.
Okay, now imagine it got buckled. So can you
Yes, sir.
derive an expression for buckling load or something like that?
Yes, sir. We can
Yeah,
derive
do
the
that.
expression very. Yes, sir. So expression would be the stresses that develop are equals to alpha into alpha is the expansion coefficient T into elasticity, which is equal to pi square EI upon equivalent length. If it is a fixed beam, then
Mm.
equivalent length would be L by 2 square. So alpha TE is the stress,
So here we
right? And
have
this is
fixed
buckling
support
load.
on the both the ends. We have fixed
Yes,
support on
sir.
the both the ends.
Yes, sir.
So
So
what will be the
fixed support,
equivalent load?
half of it, sir.
Okay, good, good.
Yes, sir.
Yeah,
So
go ahead.
alpha TA equal to pi square EI upon L equivalent square into 4. E कट जाएगा. So what we have to take out is the temperature. So what we have to actually take out, sir?
What's your expression? I'm more concerned about expression later on.
Sir, expression is T is equals to pi square
It will be delta T if
upon.
I'm right.
Yes, sir. Oh, all right,
Alpha
sir.
delta
Delta
T.
T.
Yes, alpha delta
Yes,
T.
sir. Alpha delta TA equals to pi square EI by L square into 4.
Correct. There is a ratio we talk about in buckling. What is that
Yes, sir.
ratio?
The slenderness ratio.
Correct. Now, why there is no slenderness ratio in your expression?
Um, Sir, it is there, sir. If it is actually radius of under root of K by L.
Correct.
So it could be converted into K by L very easily. If
Oh, you have written
we,
pi square EI.
yes, sir.
Okay, good, good. Then that's fine. Okay. Sometimes we also light in terms of lambda square as well.
Yes, sir.
So that's good. Yeah, good one actually. So,
Yes, sir.
can you draw Rankine cycle? What is a Rankine cycle and
Yes,
where do we
yes.
use it?
Yes, sir. So Rankine cycle is a steam cycle, steam turbine, steam cycle, in which has a very good efficiency, approximately equal to Carnot efficiency if there are no losses.
Can you repeat the last sentence?
If there are no losses.
Okay, are there
Uh,
any losses in Rankine?
Sir, losses could be of the form like in turbine, if a turbine there are losses,
So,
isentropic, if it is not
so
isentropic.
Rankine cycle gives you efficiency as good as Carnot cycle.
Yes, sir.
Okay, I'll give you one more chance to correct your sentence. Okay, that is not correct.
Uh,
Okay, what is Carnot cycle and what is Carnot efficiency?
so Carnot cycle is the cycle with two isothermal processes, compression and expression are isothermal. No, sir, heat addition and rejection are isothermal and compression and expansion are adiabatic. In
Mm-hmm.
isothermal process, it has the highest efficiency. And isentropic efficiency is the isentropic is- Carnot efficiency is the work, Carnot work, which is a
Okay,
denominator
wait, wait,
and
wait. Think and then
yes, sir.
speak. Think and then speak.
Yes, sir.
Take your time.
Okay, sir.
My question is, what is Carnot cycle and what is Carnot efficiency?
So Carnot efficiency is 1 minus TL upon TH, and Carnot cycle is simply the graph of thermal, isothermal processes and adiabatic processes.
Correct. Now, what does the second law, what can you comment about Carnot efficiency?
So Carnot efficiency is the efficiency. So what can I comment on it? So this is the maximum efficiency.
Correct. This is the maximum. And can you achieve more than Carnot efficiency?
No, sir.
Correct. Now, come back to Rankine cycle.
Yes, sir.
Can you now think about something like that?
So Rankine efficiency is lesser than the Carnot efficiency, sir.
It's much, much lesser than Carnot efficiency. Carnot cycle, is Carnot cycle real?
No, sir, not real.
Yeah. And is Rankine cycle real?
Yes, sir, definitely it is the most
Yeah.
real
Now,
process.
correct. Now we actually use it. So as you can think, Carnot is a, kind of hypothetical one. We cannot have isothermal and isoentropic process.
Yes,
So
sir.
the efficiency of Rankine cycle will be always and always lower than few order lower than Rankine cycle.
Only.
Few order lower than Carnot cycle.
Okay,
You
sir.
understood that?
Yes, sir.
Now can you draw Rankine cycle for me?
Yes, sir, I can draw like that.
Draw it in TS curve, obviously.
Yes, sir.
Take the pump input as point 1.
Yes, sir. Mhm. One. If you're able to see that.
Okay, yeah. Fine. Yeah. Can you explain the processes that are happening in this?
Yes, sir. 1 to 2 is the pump, which is a isentropic process, isentropic compression. After that, there is a boiler in it that does heat addition. Basically, it is a constant pressure heat addition, constant pressure, constant temperature until and unless it converts to liquid. And if it's superheating, then it is just constant pressure, not constant temperature heat addition. Then there is a isentropic expansion process, which gives us the work. Then there is heat uh, rejection process, which is done by a condenser.
Correct. Now, do you know what is irreversibilities? What are irreversibilities?
Irreversibilities. Irreversibility in sense of thermodynamics or in sense of power plants.
In terms of thermodynamics, let's say, and power plant as well. First talk
So,
about thermo and then let's jump on power plant. Yeah.
yes, sir. So irreversibility in thermodynamics is the change in available energy, sir. The
Okay.
Yes, sir.
And in power plant?
In power plant, it is uh, uh, the the distance it is far from the reversible process.
Okay, great. Now, in our Rankine cycle, we have the turbine process, right? Pressure
Yeah.
reduction. Yeah, sorry, expansion process. And it is perfectly reversible process, right?
Yes, sir.
Correct. Now, can you add a irreversibility in it? And now tell me what will happen with the efficiency.
So we have to make expansion process irreversible, right?
Which process will get irreversible?
So the expansion process will get
Correct,
irreversible.
correct. So you have to draw that one only.
Yes, sir. So that will be an irreversible, then this will be a non-isentropic process, and the work would be a great lesser from the real value. So this will look something like this.
How will it look? Yeah, I'm interested in that actually.
So this line goes थोड़ा आगे की तरफ and
ओके,
will extend to
वैसे
the
तुमने
right
ड्रॉ
side.
किया है क्या आगे की तरफ? ठीक
Yes
है
sir,
ठीक
वो
है।
दिख नहीं रहा actually.
हाँ ठीक है ठीक है, आई
I'm more
अंडरस्टूड
liking to.
and I
Yes sir.
understood it. So what will happen to the turbine exit at this point of time due to irreversibilities? We don't want our turbine exit to be in a
Yes sir,
wet
right,
zone a
right.
lot, right?
Yes sir. Yes
Why?
sir. Sir, it will corrode the blades and it will damage the blades.
Corrode is not the very correct way. It was erode the blade. Okay, corrosion happens, but it's mainly the erosion. That wearing out due to that
All
water
right sir.
molecule.
Yes
Yes,
sir.
that's what we are more concerned about. So due
It
to
will
yes, yes. So what will
it
happen due
will
to this irreversibility?
yes sir. Okay sir. Yes sir.
What will happen due to this irreversibility to that turbine outlet, turbine exit?
Hmm. Hmm. Sir, due to the irreversibilities, this will happen less because, sir, it has went far from the wet zone. It has come closer to the superheated zone, sir.
Okay. Now, can you tell me why do we have condenser in a power plant? Why don't we just let the steam go away in the atmosphere itself?
Yes, sir.
What's the application or purpose of condenser?
The condenser, when the heat is rejected, so due to condenser, we can recover that heat. So main purpose is the water quality because there are two purposes actually. First purpose is that we can connect it with a heat exchanger and we could utilize the heat that
No,
we are
we
rejecting.
we don't really utilize that heat. Okay, that's very low quality heat, very low grade heat. So we
Yes, sir.
never use it.
Okay,
I
sir.
mean,
Sir,
just
so,
talking about reality, we don't use the condenser heat.
yes,
We
sir.
have cooling tower in the power plant.
Yes, sir.
How do they look?
So very large, like a parabolic cylinder. They are like a parabolic
Yeah,
towers.
something like this. Okay, very
Yes, sir.
large one. Yeah. So
Yes, sir.
essentially, it is there to lose the heat, and we just let it flow in the atmosphere. We don't use
Yes, sir.
that heat actually.
Yes, sir.
Yes. So point being, we can't really use that heat. Yeah. Now come
Yes,
back
sir.
to your second purpose.
Sir, that is a pure water. We will lose that pure water that we are getting from
Correct.
the
Correct. I
turbine.
mean, essentially, we will have to reprocess the water, bring out new water, and those kind of thing.
Yes, sir.
That is correct. Can you think of anything else as well? Your answer is correct.
Yes, sir. Anything else could be um,
Do you
no,
know
sir.
what
I am
is
unable to
typical?
say.
Okay. Do you know what is typical condenser pressure?
Typical condensation. No, sir. Sorry, sir.
Okay, it is somewhere around 10 kilopascal.
Okay, sir.
And what is atmospheric pressure?
One bar, sir. 100 kilopascal.
Correct, around 100 kilopascal. Now, can you think of something? I have given you a hint.
Mm-hmm. All right, sir. Yes, sir. To take it to the very lower pressure so that a more amount of work could be generated.
Correct. So essentially, if we let it flow in the atmosphere, the
Yes,
turbine exit will be at 100 kilopascal.
yes, sir.
But now we are able to recover that extra 90 kilopascal as well.
Yes, sir.
So yes, so that is true. Correct.
Yes, sir.
Correct. So here is a question for you. Let's say you have two spheres
Okay, sir.
and they are made up of different materials,
Okay, sir.
but they have same mass and same diameter.
Yes, sir.
Obviously, they are made up of different materials, so they will have different densities. So one is
Yes, sir.
hollow, one is totally solid sphere.
Yes, sir.
Should I repeat?
No, sir.
You have
Mm,
two
One more.
spheres of different density.
Yes, sir.
They have same mass and same diameter.
Okay, sir.
And because of density difference, one is hollow, one is solid.
Yes, sir.
Now you have to identify which one is hollow, which one is solid. How can you do that?
They have same mass and they have densities that are different. Mass is same.
Yes.
So mass upon volume is density. Density mass is same. And they are of same volume also. No, 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 they are not of same volume.
Their
They have
diameter is
same,
same.
the diameter is same. Sir, we will put them in the water.
Okay.
Then what will happen is that the as they have same volume and same mass, so so the density of the hollow sphere will be lesser. But I'm unable to think right now. Sorry, sir.
Okay. So one is hollow, one is solid one. You are you able to comprehend this?
Yes, sir.
Yes, because the one hollow it will have higher density, the one who is solid it will have lower density, right?
Okay, sir.
Okay, are you
Why,
able
sir?
to get it?
No, sir. I am not able to get it.
Okay, so let's say density is rho 1, rho 2.
Yes, sir.
Mass is same.
Yes, sir.
Volume will be different. Now, what is mass? Mass is rho 1 V1 into rho 1 V1 equal to rho 2 V2, right?
Yes, sir.
Correct. Now, as I told, rho 1 is greater than rho 2.
Yes, sir.
So, V2 will be greater than V1.
Yes, sir.
Yeah. So, one will be hollow and one will be solid. Which one will be solid?
Solid will be the one with lower density.
Correct.
Sorry,
Correct.
high. Yes, sir.
Correct. Lower density.
Yes, sir.
See, hollow means it has some void inside it, right?
Yes, sir.
Yeah, that means it has a lower volume than the solid one.
Yes, sir.
You understood that?
Yes, sir.
So now the problem reduces to you have a hollow sphere, you have a solid sphere
Yes, sir.
of same mass, same diameter. How can you identify, how can you differentiate these two?
Point forces rho GV. Sir, I am unable to think, sir, till now also.
Okay. Are you aware of moment of inertia?
Yes, sir.
What is moment of inertia?
The moment of inertia is the when the mass is rotated about an axis, then the weight, first moment of second moment of mass is the moment of inertia, sir.
Okay. Now what is second moment of mass? So you are answering the question by question itself.
Yes, sir. Sir, the second moment of mass is when the mass at a distance r is multiplied by
So what do you
square of the
mean by
distance.
that? Okay, so that's a formula. I totally understand. But what do you
Yes, sir.
mean by moment of inertia? If I say an object A has higher moment of inertia than object B, what do I mean by that?
Sir, it means that it will carry larger energy.
Not exactly. Okay, here is the question. Let's say object A has higher mass than object B.
Hmm.
What does that mean?
Object A has higher mass than object B. That means that
Think
it
in terms
will
of
uh,
inertia. Think in terms of inertia.
it will have higher inertia.
Correct. Now, what do you mean by inertia?
Inertia is the ability of a body to carry some energy when it is in motion.
Not exactly. Actually, it's ability of the body to, change in its motion. So when I say object A has higher mass, that means if I push object A, I will require a higher force.
Yes, sir.
Are you getting it?
Yes, sir.
Now, can you think of moment of inertia in this term?
Yes, sir. Moment of inertia is a body's uh, the amount of energy required
Don't go
to.
into energy. Why are you going into energy?
Yes, sir. The amount of force required to change the rotation of a body is its moment of inertia.
Correct. Now, do we have force in moment of inertia or we have something else? Do we have force in rotational mechanics or we have something else?
No, sir. We have torque in rotational mechanics.
Correct. Now, can you correct your definition?
Yes, sir. Sir, the torque that required to rotate a body is the moment of inertia.
Correct. Now, can you come up to that question of, a solid sphere and a hollow sphere? Now, can you answer that?
Okay, sir. Yes, sir. Definitely. Sir, with the body with the body with higher density will have higher moment of inertia. So what we know is that the solid body will have lower moment of inertia. So what we will do is we will rotate them. If the body which is taking more amount of effort to be rotated is the
Correct.
hollow body.
Correct. Correct. Now you are at the very absolute answer. We will just try to rotate them. Which one feels heavy? Which one takes more effort?
Yes,
That
sir.
will be the hollow one. You
Yes, sir.
understood the question? You got the answer?
Yes, sir. I got the answer.
Okay, great,
Thank you,
great.
sir.
That was a
Yes.
good setup actually. You were able to think, you were able to think step by step. It's okay. This type of tricky question are not expected to be answered in a single manner. That's totally all right. So don't worry about it. Okay, Kunal. So I'll conclude your session now. Okay.
Okay, sir.
Okay, great. So just a minute. I'm getting a call to tell you should be able to tell its example as well. Okay.
Okay, sir.
And also your introduction was not prepared one. I can feel it. Okay,
Okay,
you
sir.
prepared it just
Yes,
in
sir.
front of me right now and talked about it, right?
Yes, sir.
Yes. So what you should do is take a pen, take a paper, and write
Yes,
down
sir.
your introduction on it
Okay,
and
sir.
revise it because what happens is, that's your starting of the interview. So it
Yes,
should
sir.
be fluent. You are not fluent about it.
Yes, sir.
Now that is okay. It is your first time, so that is totally all right. Point being, ki, whatever mistake you are doing here, don't repeat those there as well.
Hmm.
Okay. Yeah. That's the
Hmm.
point of having this mock discussion. Okay.
Yes, sir.
Then your answer to why HPCL, it was not very precise to be honest. Okay, you were telling about the deputy general manager. I could find it on Google and I want to be like that. No, don't be like that. Be little specific about why you want to join HPCL. You should have a good answer.
Okay, sir.
Maybe you can connect with your final year project or your internship that I interned here and I got I got excited or I liked how the whole petroleum industry work or how the energy sector work, and that is why I would like to join HPCL.
Okay, sir.
Okay, don't be that deputy general manager. Even I didn't understand what you were trying to say,
Okay, sir.
and you look little nervous actually all the time. Unless and until you are pushed a little, you look nervous. Okay, try to
Okay,
showcase
sir.
some confidence.
Okay, sir.
As they say, you fake it until you make it. Okay, so fake your
Okay, sir.
confidence. अभी जैसे तुम बात कर रहे हो अच्छे से वैसे बात करना चाहिए तुम्हें नॉर्मली भी.
Okay,
Okay,
sir.
then your favorite topics I ask you, you said heat exchanger boilers. Now tell me, are these even subjects of mechanical engineering?
No,
No. So
there are
all
topics.
yeah, those are topic. Don't go to topics. Okay,
Okay.
because see, these are very vast topics, boilers, heat exchanger, and we just might not be able to touch it. I mean, not
Oh,
we, the
yes.
people they are sitting there, they have experience of 20 years and they would know so many different things about boiler that we
Yes,
would
sir.
never do that. So because of that,
Definitely.
stick to basics, stick to the basic fluid mechanics, thermodynamics, heat transfer, refrigeration, air conditioning, strength of material, machine design, something like that.
Okay.
Don't keep them very specific. Keep them as topic of mechanical engineering. You understood?
Okay.
So that is
Okay, sir.
overall my review actually. You do good. You have good technical, but I think you need a little brush up.
Okay, sir.
Okay.
Sir, I have to ask some questions from my
Okay.
side
This
also.
might meeting might end. So can we connect on call maybe directly? That works.
Okay, sir. Okay,
Okay.
sir.
Or you
That
want
would
to,
be great.
or I will send you another link maybe right away. You join with that one.
Sir, anything would work, sir. Call, video, it doesn't matter. I just had two, three questions, basic
Yeah,
questions
definitely.
like,
That's what
yes,
I'm
sir.
saying. So I'll send you a
Yes.
link. You join in. Okay. I'm
Okay,
ending
sir.
this meeting.